This lesson is called How to Interpret Remainders. So today we're learning about what to do when you end up with a remainder in a division problem. What are you supposed to do with it? In the real world, whatever the context or the situation or the story is, will tell you how to make sense of the remainder. So let's say that we have a problem in our lunchroom. Let's say that in our lunchroom there were 135 fifth grade students, and each table in the lunchroom sat 6 students. So this isn't really our lunchroom, but let's pretend here. So we've got 135 students, and each table seats 6 students. All right, so we have some note facts here that are going to be important in figuring out how to approach this problem. So, how many tables are needed to seat all of these 5th grade students? Well, let's solve that problem. We have 135 5th grade students that need to be divided evenly into tables that seat groups of 6. So, 135 divided by 6. First things first, estimate. E is for estimate. Let's keep the 6 the same. It's a 1-digit number, so we should be able to find something that we can work with. 135, compatible with 6? How about 120? That's pretty close to 135. Why do you think I chose that? Well, because of the 12 and the 6. 20 groups of 6. So our estimate is about 20 tables. About 20 tables. All right, well, let's approach this actual problem over here. Maybe our estimate can help us. Could we take 20 groups of 6 out? Yeah, our estimate shows us we've got enough for that. So let's take 20 groups out. That would be 120. We can take those out. We're left with 15. How many more groups of 6 could be taken out of that 15? Because this means we have 15 students left that haven't been seated yet, and they need to go to these tables that hold 6. Well, I know that 6 times 2 is 12, and that's about as close as I can get to 15 without going over. And I have a remainder of 3. Okay, well, we're interpreting remainders, so maybe we should do that step last. Let's figure out our whole number, though. 20 plus 2 would be 22. Does this make sense? Check your estimate. Our estimate was 20. Yeah, really close. Okay, good. So 22 tables. Remainder 3. Would it make sense for our final answer to be 22 remainder 3 tables? Is that the right way to make sense of that remainder? What is a remainder 3 table? What is that? Well, okay, that's not going to work. What about 22 and 3/6? Oh, which can be simplified into 1/2 tables. So 22 and a half tables. Well, I don't know about you, but I don't think our custodians are going to want to start sawing tables in half. What about these 3 leftover kids, though? We can't just say, oh, 22 tables, that'll seat them all. The rest of them can sit on each other's laps. Nope. 22 tables isn't going to work either. What do we do with these last 3 kids? Well, we have 3 more kids. Maybe we need 1 more extra table for them. So really, to answer our question, we need 23 tables are needed. All of those other solutions didn't make sense with the context of this problem. 23 tables are needed. Otherwise, you've got kids sitting on laps or sitting on the floor or standing to eat, or you've got the custodians coming in and sawing a table in half. It doesn't really make sense. If it says how many tables are needed to seat all these fifth graders, we need 23 tables. So we need one more extra table for those 3 extra students. Now, here's a question. How many tables will be completely filled? Well, we said over here that 3 kids are going to be sitting at one of the tables, but the table can actually hold 6. So one of these tables is only going to be half full. So how many tables are actually full? That would be our whole number here, 22 full tables. 22 tables will be filled. Okay, great. Another question. How many kids are going to be at the table that's not filled completely? Hey, that's our remainder. 3 kids are going to be at the table that's not filled completely. Running out of room there. So, when we're interpreting remainders, we can actually start to ask ourselves a series of questions. Our first question is, how many tables are needed? That's the basic. But then we also kind of want to picture it. Okay, so how many of those tables will be filled? How many won't be filled? That's 1 table will not be filled. How many kids are going to be at that? That's our remainder. So that's how we can interpret or understand or do something with the remainders. And that's a very practical application. Here's another problem from the real world, the field trip problem. Okay, let's say that there is a group of 86 students and adults, so people all together, that is planning to travel to a play. And they are going to be using vans instead of buses that the parents are driving. So the parents are driving vans, and each van holds 8 people in each van. So, couple of questions. How many vans could be completely filled? How many vans are going to be needed in all to get all 86 adults there? How many empty seats will there be in the van that's not filled? So we've got lots of questions to ask, but first we can start with a basic division problem and then figure out what that remainder tells us in the context of this story problem. So let's set up our division problem. We have these 86 people that we need to divide evenly into vans that hold 8 people. So we're dividing the 86 people into groups of 8. Let's estimate first. We should keep the 8 the same. 86, ooh, that's close to 88. That would be 11. Okay, so about 11 vans, somewhere in there. All right, well, now let's divide here. I can use my estimate to figure out what my first move should be as I approach this problem. I don't have 88, I only have 86, so it would be silly to try to take out 11. But I could take out 10. 10 groups of 8 would be 80. And I'd have 6 left over. Okay, so here's the remainder. We'll interpret that and deal with that later. 10 is my only part of my quotient. So 10 can go up there, and I've got a remainder of 6. Okay, so let's take one question at a time. First question, how many vans could be completely filled? Completely filled. Well, that's right here. 10 vans are going to be totally filled up without any extra seats. Totally full. So that's one of our answers. 10 vans will be full. Next question, how many vans will be needed to get all these people there? Well, we're not going to sit on laps with these 6 extra people. That's illegal and completely dangerous and awkward. We can't have 6/8 of a van. I mean, what do? Chop off a tire? So that's not going to work. It looks like we need a whole nother van so that these leftover 6 people can get there. So we don't just need 10 vans and say, well, sorry guys, not going to work for you. No, we need 11 vans. 11 vans are needed. And one more question. How many empty seats will there be in the van that's not filled? Well, picture this. So if we're looking down on the van, we've got our driver and our passenger there, and then we've got some more seats. So that's an 8-seat van. We know it has 8 seats because of our fact here and our divisor. Well, these 6 people are going to take up 6 of those seats. 1, 2, 3, 4, 5, 6. So how many seats are left over? 1, 2. In other words, 6/8 of the van was filled, which means 2/8 of the van is not filled, or 2 seats are left over. 2 seats are empty in the unfilled van. So maybe Grandma and Grandpa can crash the field trip and come along. Ready or not, here's your task. Okay, this is a 3-part task. Part 1. Mrs. T bought 4 boxes of crayons, and each box had 64 crayons in it. What is the total number of crayons that Mrs. T bought? So think, 4 boxes, each with 64. How could you figure out the total number of crayons? That's part 1. Part 2, Mrs. T wants to give each of her 30 students an equal number of those very many crayons, which you found out with question 1. So how many crayons should each of these 30 students get in order for each student to get an equal number of crayons? We are not breaking crayons. So you're going to have to interpret a remainder if you get one. We are not breaking crayons. Part 3, how many crayons are left over, if any? And part 4, how many more crayons would Mrs. T need to buy in order to use up those leftovers and still have each student end up with an equal amount of crayons? Maybe they each get 1 more, but how many more crayons does she need to buy? All right, so this is a 4-part question, because we're interpreting those remainders and we're making decisions based on what the leftovers are saying. So make sure that you work carefully, because all of your answers depend on your answer for part 1. So if you get part 1 wrong, all of your following answers are going to be wrong too. So work really, really carefully. Be prepared to share your work with your discussion groups tomorrow.